Okay, let's begin. Question number 7. So the function f is given by fx equals to x cubed plus x minus 1. So let me just write that plus x cubed plus x minus 1. So determine whether or not the curve just has any turning points and explain why the function has an inverse. Okay, it's a bit of a unique terminology there. So first, please notice there's a cubic. So turning point, okay, when they talk about turning point, first we need to find the first derivative. That's the first differential. It's a fancy name, huh? And you put this on plus 1. Okay, and then to find turning point, whenever turning point occurs, it's when the first derivative is, there's a big word for dy dx, what we commonly term as dy dx, can also be written in functional form as first with the prime, f prime x like that. That's read it like that. And then we put it equal to 0 and solve for the value of x. So that is why this idea here, just the idea behind it, we're doing it here. So we put it equal to 0. So when you put it equal to 0, you realize that there are no solutions. How do I know that? Because you can immediately solve it and realize that x squared, it says x squared equals to -1/3. But squares are non-negative, so it's impossible, because squares are either 0 or positive. So the impossibility tells that, so the whether or not part we need to answer first. So whether or not the curve has any turning points, it has no turning points. So the answer is no turning points for this curve. Okay. So if it has no turning points, means what are turning points? Turning points they call like that because the dy dx kind of like turns. So either like that or like that. That means they're either a local maximum or a local minimum. I use the word local strongly because sometimes they're not the absolute maximum. That means the function can even go to infinity. But in that locality, because the dy dx, must understand what the dy dx is doing. It's talking about, it's computing this tangent lines gradient. That's what this is. So at the top here, sorry, at the peak here, it becomes 0 before becoming negative. Which is on the point, huh? My drawing is horrible. So like that. Here it's just like negative and then 0, then a positive. This is negative, 0, positive, because continuous values must change. It means this is positive. It must become 0 before turning to negative. It doesn't jump unless there's a point of singularity, point undefined or something like that. That's the logic behind it. That's the logic he used to discover calculus, because there was a very graphical dependency, okay, when it was first done historically. Okay, so no turning points means this thing cannot happen, because when this thing cannot happen, we have a unique situation where, if you notice, when you draw a line parallel to the x-axis, that means the y equal to something, this kind of lines, see, all this will have 2 intersection points. So the function it's not a one-to-one function, so it cannot have an inverse. So that is why this statement comes in. Explain why the function has an inverse. So the function having no turning points, with no turning points, okay, in that interval or sometimes interval, but in this case doesn't matter. With no turning points means it is a one-to-one function. One-to-one function means when you draw a vertical or horizontal line, you only have one value. That means it's one for each x is a unique y. That's what it means. So that's all you need to say for the real answer. Just explaining it further. You may wonder why I say vertical or horizontal. Normally books will say horizontal only because they define the function in respect to the x-axis. We can just mirror it the other way around as well. So just in case, it can also mean like that. Okay, to take it a bit more deeper or more accurate in a way. So let's evaluate this now. So what is the inverse of this? F -19. The trick is not to go and try to find the inverse, because this is a cubic. Unless you're very well versed with the completing the cubic, they actually can. This is called the reduced cubic. What is that? Depressed cubic. Sorry, almost forgot this term. X cubed plus x, because the history has it in Cardano and its mysterious depressed cubic. Then we showed that every cubic can be reduced to a depressed cubic, and the depressed cubic can be done further. Depressed cubic means doesn't have an x squared term, if I remember correctly, and then it can be shown to go to a formula. At most, we can only do that for a cubic. Quintic and above, there's no solution. That's what Abel proved. I tried reading Abel's proof once, couldn't really understand to some point. Then I gave up and never picked it up. Okay, anyway, let's continue. Just some things for you all to research if you all are very keen on this kind of deeper aspects. So we let f negative 1y equals to x, for example, and then 9 equals to fx. Aha. So you bring it up like that. So then we solve the equations better. So remember, so you notice the shortcut trick. I've never got numbers. You can always use this kind of tricks. So easy to think about it. So x cubed plus x, you bring this minus 10, right? Equal to 0. Okay. So we want to find the value of x. In other words, find x. So I'll just also indicate that. X cubed plus x, bring that minus 10. How do you even do such a, what is the word, a question? A cubic one, you must guess one of the roots. That's quite normal across exam boards. You can easily see that x equals to 2 is a root. Aha. By the fact that the derivative doesn't have this one, okay, you'll see that. But let me do it manually. So x minus 2 is a root, means factor theorem. X minus 2 is a factor. Aha. Do a bit of a polynomial division aside here. It's a bit too advanced for net match. Maybe the old papers are more advanced sometimes, more like a form 6 or A level question. Okay, just point. So 0x squared, just add a 0. Easy, 3, 2, 1, the power, then no x. Like that. Let's try to write it nicely, please. So I'll just do it so you can learn some tricks. X squared like that. So this is x cubed. When you multiply, it becomes minus 2x squared. So when you subtract, this whole thing, imagine it's a bracket like that. That's what we're doing. It cancels off. This becomes positive, negative, negative. 2x squared plus x. Then this becomes plus 2x. We always try to equate the first leading term. 2x squared minus 4x like that. Aha. So minus minus. When it's a bracket like that, minus minus plus again. 4x minus 10. It would perfectly factorize. If not, we should factorize perfectly. Yeah. Wait, let me see. Oh, it's a 5x. Almost finished the sentence with the wrong term. Because x minus minus 4x. So 5x minus 10 because it's a root 1. So it's a root there. It means, in other words, what I'm trying to say is I do this, there will be no remainder. That's how you know you did it correctly when it's a factor. Aha. So that means this x cubed thingy plus this thing blah, blah, blah can be factored as follows. So when you factor it nicely, you take the x minus 2 as the first factor. As per the color, you can see where it comes from, the number. Easy to see from where do I match. The pink color, this one, that's the upper part. So this times this. Oh, this is the meaning. So this equals to 0. So either x equals to 2, as you can see in the left. Aha, I already guessed the root actually. So most likely the answer is going to be x equals to 2. But we have to prove one more thing, which is why this part has no answer. So it's quite easy actually, although it looks kind of daunting. Why this part cannot be 0? Y cannot equal to 0. Let's put a question mark. Because x squared plus 2x plus 5 is equals to, when you complete the square, x plus 1 square, square 2x, and 1 plus 4. So it's always going to be at least 4, bigger or equal to 4. So it's going to be bigger than 0 for real numbers. So that means there's no way it's going to be 0. So the only answer, the x f negative 1, 9 is 2. Thank you.